Before we move on from linked lists altogether, let's discuss an obvious limitation that makes our list not so useful in the real world. What is that limitation? Well, let's consider here an slist using class. It creates an slist with the number 5 and adds the number 10, and it'll all work beautifully and wonderfully. But suppose we wanted to create not a list of integers, but a list of, say, strings. So I might try and start off with bone, then add thugs. And if I try running this, well, then I run into an issue. String cannot be converted to int. And so the fundamental issue we run into is that an slist has int nodes, and int nodes have int items, and therefore, if we tried to create an slist using a string, or we try to add to such an slist using a string, we will get an error. You cannot do this. You cannot take strings and convert them into integers. That's the ultimate trouble. So how do we fix that? Well, the lamest possible way we could fix it is we could make an entirely new slist class, like string slist, and then do a find and replace for int everywhere, and oh boy, and that would be a terrible idea, obviously. So the current approach in modern Java is to make slist a parameterized. Well, we can parameterize the type that slist will take. What does that possibly mean? Okay, so what I'm going to do is I'm going to add new little angled braces here right after the name slist, and here I'm going to pick any old string, something arbitrary, like I don't know, Loch Ness. And that's just going to act as a placeholder for a type that is not decided at the time slist was created. So instead of an int item, we're going to have a Loch Ness. Instead of creating an int node, we're going to say a public int node, and we need to provide a Loch Ness. Int node's probably not a great name since it's no longer int node, so let's do a find and replace on that too. So int node, we'll just call this thing stuff node, whatever, all right. Just to emphasize it still has stuff in it. And then I'm going to keep working on my way through. So when we create an slist, now we'll take Loch Nesses instead of ints. We add Loch Nesses, we return Loch Nesses, we add Loch Nesses. And at that point, we're all done. Okay? So the important part, the main thing I changed other than just the name of int node, is that I added Loch Ness here. This will compile, and now an slist, I mean it won't run because there's no main method, but it compiles and it should work fine. How do we actually use one of these things? Well, now, if we wanted to make an slist, we're going to now need to specify a type when we create a slist. And we'll do it with the angled braces. And so to do that, I'll say I want an slist of strings. So here we go. We say I would like to declare an slist of string variable and instantiate an slist of strings. And now when we try running this, everything should work fine. Okay, so there it went. It worked. Hooray. And so what's going on here is that whenever we instantiate an slist, this string right here, this string right here will get substituted everywhere in for Loch Ness. So it's basically a type variable or a type parameter. And so it can get a little confusing, and we're not going to talk a lot about it right now. I just want you to know the basics. Now, in even more modern Java, it is no longer necessary to specify the type on the instantiation side. So I'm going to delete that. And this too will work. Okay. So let's just summarize there. And later in the course, we're going to dig a lot more deeply into this issue. But to summarize what we've got here is we can defer type selection until later, until we've declared a variable or until we've instantiated a variable. And to do that, we pick any arbitrary string, and in the class that we're creating, we just put it right after the name. And then when we want to use it, we make sure that we specify the type we want when we're declaring, and optionally when we're instantiating. So again, we'll go into this in so much more detail. There's a lot of little details that can be confusing, but these are the rules of thumb you'll need for project 1, where you're going to build a generic list. So in the Java file where you implement your data structure, this side, where you're building the actual thing, you'll specify your generic type only once at the very top of the file, right there, bleep blurp, right? And it's specified inside of these angle braces. You can use it elsewhere, but you'll only specify it once. And then in Java files that use your data structure, you'll specify the desired type just once. You'll do it whenever you declare the variable, and then use the empty diamond operator during instantiation. I mean, you can also write out double, so you could technically use it twice, but this will make your code look more like what you're likely to see in the real world. And when you're actually declaring or instantiating your data structure, whenever you're putting something inside of these braces, you want to make sure that you use capital I integer, capital D double, and so forth. So use the reference type corresponding to each of the primitive types. So that will get you as much as you need on project 1. And there'll be a couple little tiny gotchas that will be mentioned in the project 1 FAQ, and we'll get into generics more somewhat later.